Go from there. Thank you.
Thank you. So hello, everyone. My name is Nicolas Demoulin. I'm from Microchip in the Secure Products Group. So for those who attended to the pen test partner presentation from Nigel, you might have understood that security is starting to be mandatory, even though in embedded design, especially as well for a small end device. Even if you're only monitoring temperature, you need to add security. So the great thing is that the market is really moving to security, hardware security. We've seen that tremendously in the past years. And we're going to present a solution which is based on LoRaWAN and TT and TTI solutions. But let's recap a little bit, some few words about security. So security is really large when you take it into the embedded system. In addition to the embedded system, you need to embrace security globally, including the cloud, users, legislation. And this is a list of some security features that can be embedded in a secure system, so which are run through different type of components, microcontroller, microprocessors, secure elements, network controllers, FPGA even. But the base of security is definitely trustable identity, so to set up a hardware root of trust. And this can be done with secure elements, okay? So it's just to trigger a math with a key, okay? So when we talk about key, this is really the base of secure system. It's all about the key. So we all have keys to enter back home. Do we let the keys on the door lock? The answer is no. So should you let the key to anybody else than you or your system? The answer is no. So it's a market statement that you can use any crypto system, which are obviously public one, not obscure one. That needs to be studied. And it's a market statement that your enemy knows your system. He can know your system, but if he knows your key, there the tricky thing starts. So the aim is definitely to have a secure key storage, hardware secure key storage. We've seen that several years ago, a lot of customers were implementing software key storage, and with something like $2,000 today, you can ask a lab to reverse your code, get back the key, get back the code, and then impersonate the device. If I have the key, I'm you, and this is not something that you would like to do. So how to protect the key? The keys needs to be stored securely in a hardware. For sure, you can implement microprocessor, which have secure key storage, which are dedicated to point of sales terminals, for example, application. But do you really want a microprocessor running Linux into your embedded system, which is boundary protected? The answer is no. So today, there is no solution, wide solution, global solution that can support secure key storage in microcontroller. You may have one, two, reference, but that's all. So the aim is really to have a secure vault, which is a companion chip to the microcontroller, and that stores the keys. That's all. That also have a crypto engine, sorry. And then the microcontroller sends a random challenge. There is a computation between the crypto engine, the random challenge, and the secure key, and it answers back the microcontroller to confirm that the identity is genuine. So whenever you have confirmed the identity, you can start the whole process of booting your end device, of starting communication with the network, and starting the secure authentication protocol. Okay, so talking about LoRaWAN now. So LoRa is a network with nodes, with gateway, with server. And whenever you have a network, you need security, and you need to trust the end device, and the end device needs to trust the server. So how to do this? LoRa, due to the low bandwidth architecture, in order to perform battery-powered application, very low power battery-powered application. The architecture is a pre-shared key. So the same key needs to be in the end device and in the application or network server. So for that, you need to share the key. How can you share it securely? Today, we've seen a lot of customers, they are sharing keys through emails, through Excel file, even through papers. This is totally insecure. No security at all. So, the authentication for LoRaWAN, so I'm going to talk about the 1.1 specification. The solution we are providing is definitely supporting both LoRaWAN specification, but let's talk about the 1.1. So you've got an application server key, which derives an application session key. And same thing for the network key. So the network key derives the network section key. And then you've got connectivity on the network and application server. Thanks to both keys, which are the same on the server side and on the end device side, you can make secure authentication. Okay. So what are the vulnerabilities today in LoRa? Again, I mean, the crypto and the security set up by the LoRa Alliance is great. It's great security. Pre-shared key is great, especially for such kind of end device. But due to the fact that you need to secure the key, we have today some vulnerabilities. So often in end device, the keys are stored in flash memory. Again, flash memory, $2,000, and you can reverse the code and get the keys. So it's definitely subject to counterfeiting and identity theft. So this is totally insecure. Then you've got vulnerability in the backend. Okay, why? Because in the backend, you've got 1.0 and 1.1 is the same. So you've got Linux system generally who's running on the network and application server. This is software. Software have bugs. That's a common statement. And again, the keys are often exposed to software and to people. So in terms of security, we are not there. Then, when you have a LoRaWAN application, sometimes you might need to rekey from one server to another one. So it can be from the application server or from the network server. And the question is how to trust the server, the initial server, to rekey your end device. So, and in addition to that, when you rekey, you need to send the new key into the end device. So same thing, how to send the new root keys, how to secure this. And then you've got supply chain vulnerability. So you've seen we have vulnerabilities in the end device, in the network, in the server, and then as well in the supply chain. Okay, so you've got the product owner, which often is different from the production, which can be a contract manufacturer. So you need to send the keys into the application server. The keys are copied, are sent, are stored, again, through email, through paper. Okay, it's not trusted. Same thing for the network server. So you need to send the key, to provide the keys from the end device to the network server. So same stuff. At the end of the day, there is a global scalability issue. Why that? Because if you have only one device, maybe you can handle this securely. But if you have many devices with many different end users, with many different running on different network server, application server, then it's starting to become a full mess. So, in terms of summary, vulnerabilities are everywhere in the LoRaWAN protocol. Again, it's not about how they set up the security and the philosophy of the security, but it's how we can securely distribute the key. And today, there is no solution for that, no mass market solution. So there are some vulnerabilities at the OEM, the product developer, at the contract manufacturer, at the backend, at the end node, and there is definitely a global scale limitation for that. So, a few months ago, with TT and TTI, we met and we wanted to get rid of those limitations, vulnerabilities, definitely. And the LoRaWAN Alliance did specify a new solution, an additional solution of the application and network server existing, which they call the joint server. Okay. So the challenge was really to distribute the keys on a global scale securely. So we set it up a global solution with TTI, which is not only a small piece of silicon, which is not only a joint server, a secure joint server, but it's a complete solution, complete offer that includes a secure element, so which is a vault, which stores securely some keys, which are pre-provisioned. So when we say pre-provisioning, it's that the secrets are generated by the secure elements in secure factories, but they are generated before the start of development of the end product, of the end device. We do not need to know what will be the end device, on which network server, application server they will run. Everything is done before at the premises. It's done through a secure provisioning flow, so it's secure manufacturing. It's process, standard process within the secure industry. We've been shipping billions of secure elements already provisioned in our secure manufacturing lines. Started 20 years ago with TPM, Trusted Platform Module business that is everywhere in laptop and PC. So this is under control. And then we bundle this with 1 year of TTI joint server service. So it means that when you buy the device, you'll be able to securely authenticate on TTI joint server for free during 1 year. Okay? What is a joint server? The joint server is typically an HSM. HSM means hardware security machine. We have the same thing in our secure provisioning services, facilities, and we have performed a secret exchange, so it means we have shared some root keys securely, for sure, between TTI joint server and Microchip joint server. And then from that, we are able to derive root keys of every device. Okay? I will explain a bit more later that case. The beauty of the solution that TTI is bringing is that they also offer rekeying. Okay? So in addition to be able to onboard within TTI joint server and then select your application server and your network server, really of your choice, you're not bundled to any application or network server, you are also able to rekey after the first connection on TTI joint server on any joint server of your choice. That has enabled the rekeying features. So now that we have implemented the solution, we've got a secure element, which is the ATECC 608A TNG LoRa. So LoRa means LoRaWAN. TNG is trust and go. So after trust and go, you will understand that it's a device that you select, you embed in your design, and you go on the market, nothing to do else. And then this device is securely connecting on TTI joint server that will derive the key and perform a secure authentication between the end device and the joint server. So how is it done? I think we mixed up the slides, so I'm going to go to the onboarding process directly. So how do you do this? You are the customer, you just order the generic part number of the TNG LoRa device for TTI joint server. Whenever we ship the parts back to you for final product assembly, we also generate what we call the manifest file. And this file contains the serial number, the unique ID of each secure element we are shipping in the order. Okay? Serial number is public information, nothing confidential, nothing private. So even if it's hacked, there's no problem for that. And then we send the manifest file in the same time as we ship the parts. Whenever the end device are ready to go on the market, the customer will upload the manifest file to TTI joint server. So in order to declare which are the each secure element that he wants to onboard on TTI joint server. And starting that, there will be, so it's a claiming process, And starting that, there will be a secure authentication that will be set up between the end device and TTI joint server. How is it done? Is because in both HSM, again, we have the root keys, and then the root keys are here to derive the network key and application keys based on serial number. So whenever TTI has a serial number, we do have the serial number in our secure element, and both process just derive the keys for secure authentication. So it's a really easy process to implement, but fully secure. So let's go back to, I was mentioning the TNG LoRa, so TNG for Trust and Go. So this part number is not a unique part number on the market here that you can buy, but just alone. It's part of our overall platform that we have called the Trust platform, and that we have declined in 3 different subcategories. So the first one is Trust and Go. So Trust and Go is devices which are already configured and provisioned. So it means that you just need to buy them, solder on the hardware PCB, take the example code, software code that we do supply, and then go into production. Here, the MOQ is 10 units. For your information on the market today, for pre-configured and pre-provisioned device, including the secrets, the MOQs, so minimum order quantities, are around 100K, 150K units per year to be supported. So here, it's just market breakthrough, 10 units. The LoRa configuration that we do provide, the ECC608A TNG LoRa, can also be used in the TrustFlex environment. TrustFlex let the customer add their own secrets. So imagine you're doing an end device based on LoRaWAN. You want to do secure authentication on the joint server, great. But you want to add also secure boot because you want to be sure that your firmware is genuine. So you're able to import your own secrets into the device that we will provision and to perform either secure authentication on the LoRaWAN network, but also secure boot. Okay. So we have few alternatives like this to add additional security features into the TNG LoRa device. So again, it's really easy model. Device which are pre-provisioned. So here we're talking about the LoRaWAN one with the application key, with the network key, and also enabling the rekeying capability. Select the part number, prototype, and code, and go into production. No need to understand any complex security concept. No need to set up whatever root of trust chain. Everything has been done between the TTI joint server and Microchip HSM manufacturing capability. Again, very low MOQ, cloud agnostic, and really short time to market. We have some customers who did implement the secure element for LoRaWAN 2 days of development before going into production. So we've made already the onboarding. So yeah, just to let you know, so we have different hardware available to implement that. So we do have what we call the SAM R34, which is a system in package integrating a very low power Cortex M0 Plus core, plus the LoRaWAN radio in one package. It's a 6x6 millimeter BGA package. And then you just need to add the secure element to set up a complete LoRaWAN service and device that enable microcontroller for your application, connectivity with the LoRa radio, and security for secure authentication. Then if you want to use this system in package, you're still able to use Cortex, AVR, whatever microcontroller, bundled with the Semtech discrete radio, plus the secure element. And here, the support of the LoRaWAN stack can be either the Microchip one or the ARM embed stack. Okay? So to onboard, really easy, just buy a kit and you're done, because the chip is already configured and provisioned. And again, it's 10 units MOQ. So you're able to start production starting 10 units. No need to invest into a lot of components for that. Okay, so in conclusion, the secure elements solution that Microchip and TTI offer are really here to ease the implementation of security, of secure authentication on a network, on TTI joint server for LoRaWAN network. In addition, it includes a 1-year service on TTI, so everything is bundled into the secure element. In addition to the ease of use, it's definitely robust security, so we have implemented state-of-the-art security for that. We are using HSM on both parts, TTI and Microchip, which are the state-of-the-art HSM done by big names of the security, and which answer to the latest security requirements. It does simplify the logistic. No need to set up complex logistic flow to distribute the key, to program the end device with the correct keys in a secure environment. Everything has been done at the start of the secure element manufacturing. And in addition to that, it's high-rated, GIL high-rated secure element, so I'm not going to go into details on that, but it's part of the GIL certification, which is a small part of the common criteria certification for TPM, smart cards, and the GIL high means that the secure element is really secure, and it has been assessed by third-party labs for that. So again, the aim is really to isolate the key from the firmware, from the user, from manufacturing operators, from the equipment, from the end user, for anybody, because they are stored secretly, securely in the secure element. So at the end of the day, it's a fully flexible and scalable solution. It's network agnostic, network server agnostic, it's application server agnostic. In addition to that, you can rekey from the joint server to any joint server of your choice. It's LoRaWAN stack agnostic, really easy to implement if it's not already done with the one we are providing. And it's a single part number. No need to do anything else than buy a part number, embed on your hardware design, take the LoRaWAN stack that we do supply, and then go into production. Again, it's a matter of few days of implementation. So I'm done this presentation. Thank you for your time. We are having a booth here, a small booth in the conference, so feel free to visit us. We have the whole package available, and we can demo this really easily. And if you have any question, I'll be there tomorrow the whole day on the booth. Thank you.